Institute for Ethics and AI. Sorry about that. Who's a senior research associate at the university's Institute for Ethics and AI, has published his book Reason and Inquiry, and that describes how erotectic theory can unify the human capacity for reason and decision making, and how that interacts with AI. Our DPhil student Alexander Petrov released a paper recently on how AI large language models like ChatGPT treat different languages differently and unfairly due to their tokenization. But today, we're welcoming St. Catherine's College Fellow, Philip Torr. He's one of our most publicly lauded fellows, and amongst his many accolades, he is a Royal Society Wolfson Research Merit Award holder. He's the director of the Oxford-based spin-out Oxsite. He's a chief scientific advisor to 5AI and a fellow of the Royal Academy of Engineering. Rarely amongst engineers, he's also a fellow of the Royal Society for his contributions to computer vision. And in 2021, he was made a UKRI Turing AI World Leading Research Fellow. Philip's contributions to science, as you will hear, go far beyond the walls of academia and are impacting many fields of engineering and our everyday lives already. Now, before I ask Philip to speak, I'll just bring up a little bit of housekeeping we've got to do. As you have just seen, we are recording this talk so that Philip's talk can be enjoyed by members of the Catz community who can't join us today. There'll also hopefully be some time for questions and answers at the end of this talk, but we'll stop the recording before that so that the Q&A can be an open and relaxed discussion and in essence confidential to the attendees in the Zoom meeting. Once the talk is finished, if you have a question, please press the raise your hand icon, which you'll find down at the bottom of the screen, and we'll try and go through those in order and get you to ask your questions to Phil directly. So without any further ado, I'll hand over to Phil.
Oh, thank you very much, David, for that introduction. It's a real pleasure to speak to all the St. Catz alumni. And I just thought, yeah, this is going to be a bit of a random walk through my career on AI. So I actually started back in the 90s over here when I was, I'd done a maths degree at Southampton, and I was really interested in I saw Jeff Hinton speak about neural networks. I got super interested in that. So I came to Oxford in 1990 to do my PhD. And I really wanted to work on neural networks, but they were really out of fashion at the time. And so I ended up, they said, well, we've got this new supervisor, David Murray. He works on computer vision. You might be able to use neural networks for that. Do you want to work on that thing? So I ended up moving into the field of computer vision and taking a little tour through it for a little while. And then more recently, my group has turned much more again into a neural network and machine learning group. So my PhD, after that, I left and went to become a research scientist at Microsoft, partly on the back of work that I did that got spun out into a company called 2D3, which I'll talk about in a little while. I worked at Microsoft Research for a few years, really liked it, but I always wanted to come back to Oxford. Oxford's such a magical place. I remember, you know, when I was a PhD looking up at the profs there, thinking they were in some sort of Olympus and, you know, thinking, oh, it'd be amazing to be a professor. And I guess one thing I learned in my life is that if you have an objective, yeah, that's probably the most important thing, actually working out what you want to do with life. Because after that, you can go and, you know, there's a procedure for working out how to get there, which is getting good mentors, good mentorship on how to get there. And so pretty early on, I thought, oh, I'd love to come back, live in Oxford and buy a house and, you know, be a prof. So I thought, one step on the way was to go and work at Microsoft. which had at the time was one of the top research institutes, and it would also give me enough money to buy a house later on. So I went to work at Microsoft, but I always wanted to come back to Oxford. And in those days, you know, this was probably the early 2000s, you had to wait for some professor to die, you know, and step into their shoes. So I thought, you know, rather than assassinate one, I'd come back to Oxford Brookes so I could still live in Oxford, stay relatively nearby, and hope at some point that you know, a position would come up. And in that time, I worked a lot with a lot of companies like Sony and Vicon to do various tech transfers. And then a position came up, and I came back to Oxford, which is amazing. You know, really a privilege to be here. And I spun out since then a bunch of companies: Oxite, 5AI, AI Static. So this talk, I'm mostly going to talk about the applications I've done rather than the theoretical stuff for a general audience. But actually, we managed to do quite a lot of fundamental advances in the fields of machine learning and computer vision. So yeah, the group itself, we work on all aspects of computer vision, and as I say, in recent years, we've moved on to working on neural networks a little bit more, and we also collaborate or advise many of the top tech companies like Google, Microsoft, Technicolor, Apple. So we've got Facebook and some of the Chinese companies which we're not allowed to anymore, like Huawei and Tencent. We have in the past. So yeah, we've worked with a lot of the top tech companies. Now, this, just in case you don't know what computer vision is, I thought I'd show a little clip. So this is from Terminator. I don't know if you remember it. It's a movie from the 80s that kind of influenced me, and it's about this robot who's sent back from the future. And you can see, as we're watching this clip, you can see it's simulating his computer vision system. So it's, if you pause this, you can see all the things that he's saying. He's analyzing the people, he's segmenting them, which means working out their shape and their outline. He's working out threat analysis and intent of the humans around him. And he's also doing sizing. So he's trying to fit clothes to people. And here he's found a perfect fit.
I need your clothes, your boots, and your motorcycle. You forgot to say please.
So the strange thing is, I was very inspired to get into the field as a child because I love science fiction and fantasy and those things. And, films like this were kind of inspirational. And everything we see in that film, actually, in other talks, I actually show the individual slides, but I can tell you it's everything from 3D reconstruction, segmentation, recognition, understanding humans. I've actually worked on, and we've largely solved now. So none of this could be done at the point of this film. And now we've reached a point where we can do it all, and some of it better than a human can do. So, it's kind of remarkable progress going from a science fiction film, in the 80s to all of this is reality now. And actually, here is a frame. So you can see, it's he's looking around at various people, and segmentation was a big thing, which I worked on a lot, working out. Both recognizing an object and then working out its outline and then recovering its shape. And this has been, a recurrent theme of my earlier work. And there's been many eras of computer vision. So the 80s were inspired by people in biology or psychophysicists. And the people in machine learning were constantly looking for inspiration from these other disciplines to try and find out what was done. And I arrived in the 90s, and I was part of a movement that kind of eschewed and moved away from that and decided to try and solve these problems based on mathematics and theoretically optimal types of procedures. And in the 90s, there was a lot of work on solving geometry and 3D construction. The 2000s, there was a reawakened interest in object recognition. And this led to something called the ImageNet Challenge. Somebody in Stanford collected this big data set of images, and it turned out that neural networks, were the winner on that. And that led to this revolution in the 2010s, where very old methods combined with, these very old methods, which being neural networks, were combined with recent advances in GPUs. So GPUs had graphics processing units for computers had undergone a revolution due to the commercial pressure of making games. So, games constantly wanted better graphics. So these graphics processing units became like supercomputers, and they were ideally fitted to neural networks. And of course, we had the World Wide Web, increased storage, so huge amounts of data in which to train them. So these old methods suddenly started to work. So in the 90s, I was on a big European project, which was concerned with 3D reconstruction for robotics and navigation. This led to a spin-out called 2D3 in 1999, which enabled 3D reconstruction of the world from cameras. And actually, one of the main users of it was in the film industry and the gaming industry, where they wanted to look at video and reconstruct it. So let's see an example. So here we have some ancient archaeological site. I think it's in Egypt. And we have like a camera panning around this guy here. And what we want to do is actually reconstruct it as it used to be. So the first thing that we worked on was tracking. So we track all these little feature points. These are the little feature points being tracked. And then the next thing is we worked out all the maths so that from those 3D points, you can do a 3D reconstruction where you work out the location of the points in the scene and you work out the cameras. And then from that, you can insert these various computer graphics things, and you can see it moves consistently with the way the camera is, and it's also reconstructing it according to how the scene might have looked. And, this was the company 2D3. It later got acquired by Boeing, and it was used in all of the main films and still is. So Harry Potter, Lord of the Rings, to insert these computer-generated characters. And, Gladiator as well. So you can see here, we have it being used. There's the Colosseum as it used to be. And then, you can see that's been inserted from this view above of the Colosseum as it is now. So, to do this involved a lot of technical advances. We had to really work on understanding the scene, and we won a few awards as well within academic conferences for this work, because it also had to be highly robust and work consistently. So robustness was a big element, and robust statistics and robust estimation was a big element of making this work. I then left and I went to Microsoft. It's kind of crazy because when I started in this field of AI and computer vision, which was in 1990, the conferences were maybe like 100 people. And nobody, before, in 1990, there were literally people saying, is this any use? We couldn't get funding. We really couldn't find people who thought it was useful. They said, this isn't going to happen in our lifetime. Why are you researching it? And there was somebody who tried to disprove them by counting the number of companies that used computer vision. And, they could only find 5 or 6. So, it was kind of coming out of like a little AI winter. And even though we produced this company 2D3, I got headhunted by Microsoft and I went to Microsoft. Microsoft was still primarily an operating systems company. And one of my frustrations when I was working there was there weren't really many applications of computer vision. So the best that we managed to do was get something into PowerPoint, an image editor, which would allow us with a couple of strokes to specify the foreground and the background. So you see this little line here specifies the background. This blue line here specifies the foreground, and it would allow you to segment objects out so you could cut and paste them. But, you know, it was just really small beer, and it still wasn't, you know, this is pre the big data era. So I left Microsoft. As I say, I always wanted to move back to Oxford. So I came back to Oxford and immediately started to have more tech transfer. And actually, I had a good 6-year collaboration with Sony where I worked on their Wonderbook. And the Sony, this is the PlayStation team. And they had something called the iToy, which was a little camera that sat on top of the television, and it would video you, and it would basically, what we wanted to do was do the segmentation to insert you into the games. And so, you know, this is a sort of graphic of it. So somebody would play
PlayStation 3.
They'd have this little book, and then, you know, they could cast spells, and what it would do is segment them, identify them, and then put them in there, and it would track their movements so they could cast some spells and do things.
Of spells.
So that was kind of cool.
Magic made real with Sony.
And the great thing about that is I got a credit on the game, and it sold 600,000 plus units. So that was kind of cool. I also worked a lot with Oxford-based company Vicon, who did motion capture. So you'd attach all of these little lights to somebody. It would track them. And then you could use that for either motion capture to either drive somebody like Gollum. So it was used for Gollum in Lord of the Rings. Or you could track somebody who had, like, say, some medical condition, so that you could analyze their gait to see how it could be improved, whether they're improving. So that was kind of very rewarding work. So that was through the 2000s. Object recognition remained really hard. I mean, computer vision is hard. You know, you think about a face here. There's all sorts of changes in illumination, which mean that, you know, even a particular pixel, you know, might move all the way from being really light colored to really dark colored. So there's huge variability in object recognition, which makes it enormously hard to do the classification. Also, huge variability in pose. You know, you look at all these deformable and truncated cats. So this can be like super hard to recognize. Big variability between, you know, even within classes and between classes. Oops. So yeah, as I say, there was this big explosion when people collected huge data within computer vision. People collected huge data sets of images and made a competition. Can you recognize them? And, you know, there was this huge jump when neural networks came along. And so, you know, I'm proud to say that neural networks, their proving ground was really within computer vision. You know, just as one of the problems I think that they still had is robustness. And, you know, that's a big thing that I'm working on now, is how to make these neural networks more robust and trustworthy. David, by the way, how am I doing on time? Okay, so
probably pretty terrible, but I think everybody's very interested.
Okay, then I'll rush through some of the applications I'm involved in now. Then, so so basically, I have 3 spinouts now: AI Static, Oxite, and 5AI, which I'll talk about. So AI Static is something I set up in the lockdown because what you know, I was trapped at home and thought, what could I do to try and do something to help? Online clothing is set to grow to $1 trillion by 2025. A lot of online sales in lockdown. Huge problems is massive waste. People order clothes, they send them back. There's a cost in sending it back. A lot of the stuff that's sent back just gets put into landfill. So really not very green. You know, big problems with online sales of clothes, which is very unethical, you know, a lot of waste and also very cost inefficient. You know, I worked a lot on 3D reconstruction, on segmentation. So why not apply that to, you know, making an app you can put on your phone, does 3D reconstruction, pops out your body, and then also allows you to try the clothes on virtually so that you can put them on, see what they look like. So that's an ongoing concern at the moment, and we've got a couple of high-end customers that we're working with, and yeah, so that's the 3D reconstruction for online sales. What another company which I set up in 2016, I was really interested when I came to the university to help people with visual impairment. So it affects more than 400 million people globally, 50% of central sight loss. And you know, what we want to do is make glasses which were configurable that allow you to enhance people's vision in various ways. So give them detect objects and really enhance them. So that actually is I'd say it's slightly in trouble because lockdown really hurt us. We had a big deal with Vision Express to distribute these, and then lockdown happened, and so you know, we lost a lot of money as a result. On the other hand, a big success that I was also involved in is 5AI. 2016, we set this company up to do autonomous cars in England. 2020, we ran the first autonomous taxi service in Croydon in London. You know, this to me was a perfect problem because it involved all aspects of computer vision and you know, from tracking to 3D reconstruction. And then lockdown hit, which was a real disaster because we couldn't take the real car out anymore. So we pivoted to safety tools for autonomous cars, doing a lot in simulation, and that got acquired by Bosch in 2022. So we got the company up to about 150 people, and then you know, it's a really happy acquisition by Bosch. And I still work a lot with Bosch now. They're funding a lot of the group. Couple of the research areas I've been inspired to work on recently as a result of this is robustness and safety of AI systems. There are these things called adversarial examples. You can take an image, you can add a small amount of noise, and then it makes the output very unstable. This is very undesirable. So working a lot on trying to make AI systems more robust. You know, and yeah, the consequences of failure of AI systems, even if it's a small chance, it can be very large because, you know, somebody dies in an accident or other type of thing, misdiagnosis as a result of this. We want to really make sure that's not going to happen. And, you know, this is really interesting because, say, hackers have shown how Tesla Autopilot can be tricked just by small perturbations of the image. So I think, you know, we really need to think carefully about safety. So yeah, two big focuses of the group are continual learning and robustness. Why continual learning? Well, it's because we're drowning in data. You know, every day there's 306 billion emails sent, approximately 500 million tweets. You know, in 2020, on average, every human created 1.7 megabits of data. You know, and these figures just start to get staggering. So we need to basically have a way where we can efficiently have machine learning update its knowledge and continually learn about the world. So, you know, that's another big topic in the group that we're working on. Yeah, this is why I'm working on robustness, by the way. There are these things in machine learning called adversarial examples. So you take an image, you can add a small amount of imperceptible noise. And here, you know, it might be classified as pig. You add this little bit of noise, it looks the same to us, and it looks like an airliner. And, you know, this, even if it might only occur, this freak pattern of noise might be insignificantly unlikely to happen. If it happens just once and it causes something disastrous, that's a really bad outcome, and so the risk is high. And it's a bit like the gimbal lock for Apollo 13. Gimbals were these things that you can use for navigation. They're like these free rotating concentric circles. There's almost a probability 0 they'd all align, but if they do, then you can't navigate anymore because you lose a degree of freedom in your navigation. And this happened on Apollo 11. Yeah, this is a problem also for segmentation. This is the image. You can add a little bit of noise and it perturbs it arbitrarily. It can be applied across different classifiers and cause problems. So just due to amount of time, I won't say too much, but you can change the color a bit of an image and it might change the classification. It's a little bit like people are saying that machines have passed the Turing test, but I would beg to disagree, because if you know what question to ask the machine, if you say, is this a pig and is this a pig, and it says pig here and airliner here, and it's just spitting out nonsense, then I would say that actually machines have only passed the Turing test because people haven't been asking the right question. And actually, you can definitely, even if the large language models produce similar results where you can ask it questions and it produces nonsense answers. So I'm very skeptical of those who are saying attributing too much to the current brand of large language models. Okay, I've nearly finished. Also working on AI for science now. A lot of the methods that I used before were based upon things called Markov random fields. So pixels could be viewed as a type of graph. An image could be viewed as a graph where all the pixels are connected in a grid. And we've been extending those methods now to non-grid-like graphs. So for instance, you might have molecules which could be viewed as a graph, and we might want to predict properties of molecules, like the properties for materials like elasticity or something like this, or the properties of drugs. How likely are they to cure cancer given a particular molecule? And at the moment, we've developed new techniques that have given state-of-the-art on the current data sets in these areas. So that's really exciting. And we're also working on methods to help predict reactions and to verify that that's correct. So, that's kind of interesting. And as I say, inspired by the work on 5AI, we're moving also more into AI safety. So if people ever want to contact me, I'm very happy to be contacted. My email's somewhere on the website. And thanks very much for listening.
Wow, thank you very much, Phil. That's packed an awful lot of information into a fairly small time. Now, at this point, we're just going to stop the recording in the process. And we'd be very happy to take some questions. And I'm sure there are plenty of people who would like to ask a question. So if you would like to ask a question,